for electrostatic field, right? Del cross E क्या है? 0 है for electrostatic field, and then there is a possibility to write this E as some gradient of potential phi. E as some gradient of potential phi. E is equal to minus grad phi. Okay. So there is no need of writing vectors again and again, because you know when two quantities are vectors, they are vectors. So हमेशा sign बनाने की जरूरत नहीं है. Okay. So ये ऐसा मैं क्यों लिख सकता हूं? Because E is equal to del cross E is equal to 0 है. So E grad of curl of grad of a quantity is always 0. Curl of grad of a quantity is always 0. So that means if you compare, E will come out to be minus grad of phi, where phi is some scalar. Phi क्या है? Scalar quantity है, जिसका नाम है electric potential. Electric potential. This quantity is called electric potential. Okay. So the definition we give, the definition of electric potential, we give by using a charge. Suppose I write a charge Q, and from infinity, I bring a quantity Q naught in the field of plus Q. So the definition goes like this: the work done per unit this test charge is called electric potential of that point. So if I write this point as, say, P, so that is electric potential at point P. So actually you can define it the other way also, from infinity to this point, or from this point to this point. Okay. But we define it like from infinity because the reference potential at infinity can be taken 0 for this case. ठीक है? So since work done is involved, let us calculate. So let us take 2 points, A and B, and calculate the same quantity. So work done will be force dot dr. This is the work done. So force will be equal to 1 by 4 pi epsilon naught q naught by r square into dr. That is the small work dw. Okay. So if you take this q naught that side and integrate, so it will become w by q naught is equal to, and suppose this work is done from moving the point from A to B. So that is equal to 1 upon 4 pi epsilon naught q naught integral dr by r square. Yes or no? And this integral is equal to q naught नहीं होगा ना, q by 4 pi epsilon naught minus 1 by r from infinity to r. So this will become 1 by 4 pi epsilon naught q by r. So this is the definition of electric potential. And if you take 2 points, So let's say you take point A and B. तो यही point A और B, अभी तो reference point कहाँ है? Infinity पे है. So देखो, किसी भी point का if you are writing the potential at some point, that means reference point you have already taken. Right? समझ आ रहा है?
Yes, sir.
So if you take reference points, like if you take VA minus VB, ये भी definition ले लेते हैं दो points के बीच में, then it will become minus integral from RB, this point will be here, to RA and E dot dr, field dot dr. So this will be the, okay? Because यहाँ पे जो force लिखा था, इसका Q naught इस तरफ कर लिया तो field ही तो बन गई, right? So this is the definition of potential difference. This is the definition of potential difference. ये note कर लो. So अगर potential difference को 4 से multiply कर दिया जाए तो work done आ जाएगा. If potential difference is multiplied by charge, then you will get work done. So that's why we use the. So see, finally we started with force, then we got the concept of field, then we got the concept of potential difference, and then from potential difference we can write energy. So ultimately it is the energy which is the most fundamental thing which we want to understand for a system. So इसलिए हम धीरे धीरे मूव करके वेक्टर से स्केलर क्वांटिटी और फाइनली एनर्जी तक पहुंच जाते हैं. So because it is the energy which is the most fundamental thing which we want to know. तो यहां तक ठीक है? देखो सारी बात समझ आ रही?
Yes, sir.
So because ये बात ध्यान से देखना कि अगर तुम पॉजिटिव चार्ज को इधर लेकर आ रहे हो तो लगातार रिपल्शन फील कर रहे हो ना, तो तुम्हें वर्क करना पड़ेगा, राइट? तो अगर वो पॉजिटिव चार्ज यहां लाके रखोगे, so that work will be stored in the form of energy. Like you take a stone and put it on the 9th floor. So you do some work and that work is stored in the form of energy in that stone. Okay? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So similarly, there is a charge and you are taking this charge, putting it here. So because you are doing some work, that work will be stored in the form of energy. So you can see that if I multiply it by charge, I will get energy, right? So that means if two charges are there like this, what will be the energy stored in it? 1 by 4 pi epsilon naught q naught by r. This will be the energy stored between these two charges. So जैसे कि मान लो न्यूक्लियस है और इलेक्ट्रॉन है at a distance of Bohr radius a naught. So what is the energy of that system? 1 by 4 pi epsilon naught minus ze square by a naught. यही तो लिखते हो? So this is the energy stored.
Yes, sir.
Okay? यहां तक कोई डाउट हो तो बताओ. Okay? Can I erase this all?
Yes, sir.
सो ऐसे ही चलो एक केस लेते हैं कि सपोज दीज आर टू पैरेलल शीट्स, इनफाइनाइट पैरेलल शीट्स। यहाँ पे है चार्ज डेंसिटी सिग्मा और यहाँ माइनस सिग्मा है, and let the potential here is VA and here potential is VB. Okay, and from some origin we can take origin on this also, right? Or we can take origin outside also. If I take origin here, let this distance is RA and this distance is RB. Okay, ठीक है? What is field in between? Sigma by epsilon naught in the direction n cap. I mean, this is suppose n cap or r cap. Let us take this r cap. So this will become r cap direction. Okay. So what is the potential difference if I want to know RA VA minus VB क्या हो जाएगा? Minus बोलो integral RB to RA E dot dr. यही तो होगा? अभी बताया भाई.
Yes, sir.
तो VA minus VB जिसको हम potential difference लिख लेते हैं VAB, that is equal to minus E बाहर आ जाएगा, फील्ड बाहर आ जाएगा because field is constant, और ये बच जाएगा dr का इंटीग्रल r, यहां जाएगा rb, यहां जाएगा ra. So this will become minus sigma by epsilon naught ra minus rb, and if you take sign inside it will become sigma by epsilon naught rb minus ra. So this will become sigma, suppose this distance is d, so it will become sigma d by epsilon naught. So this is the potential difference. कितना बढ़िया है देखो. So this is a very simple question which tells you about the potential difference, that here potential at VA is greater than potential at VB because VA minus VB is positive, right? समझ आ रहा है?
Yes, sir.
इसमें किसी को कोई डाउट हो तो पूछो. तो अगर फील्ड कांस्टेंट है तो पोटेंशियल डिफरेंस क्या हो जाएगा? V is equal to ED. Potential difference between 2 points which are at a distance d. If the field is constant, then the potential difference will be equal to V is equal to ED. Is it okay?
Yes, sir.
Any doubt in this? और यहां पे एक और बात बहुत ज्यादा अच्छी पता चली कि सपोज VA यहां है, VB यहां है. This is at higher potential, this is at lower potential. So field will be from the higher potential towards lower potential. क्योंकि field is minus of gradient of V, and gradient of V is in the direction where the potential is increasing most, and minus sign will reverse that direction. तो फील्ड विल बी इन द डायरेक्शन फ्रॉम हायर पोटेंशियल टुवर्ड्स द लोअर पोटेंशियल. जिस तरफ पोटेंशियल सबसे तेजी से घट रहा है वो फील्ड की डायरेक्शन होगी. जिस तरफ पोटेंशियल सबसे तेजी से घट रहा है दैट विल बी द डायरेक्शन ऑफ द फील्ड. So the direction of the field will be in the direction where potential is decreasing most, because that is the definition of gradient. तो अगर हमें पोटेंशियल पता है तो हम फील्ड निकाल सकते हैं बाय टेकिंग द ग्रेडियंट, और अगर हमें फील्ड पता है तो हम पोटेंशियल निकाल सकते हैं बाय यूजिंग दिस फॉर्मूला. इज इट ओके?
Yes, sir.
ठीक है, तो इरेज कर रहा हूं. ये क्लियर है सबको? तो आई एम इरेजिंग इट. ओके,
Okay.
so like using Coulomb's law, we used the field. Now at a distance r, suppose you have a charge system, so electric potential also you can write. Electric potential using a charge system, like point charge is there. So what is the potential? Small potential. For this, the reference potential is at infinity and that is 0. So 1 upon 4 pi epsilon naught dq by r. यही तो होगा. And this can be written as, बोलो, integral 1 upon 4 pi epsilon naught lambda dl by r, or integral 1 by 4 pi epsilon naught sigma dA by r, and is equal to 1 by 4 pi epsilon naught rho d tau by r. So these definitions we can use for, this is for point charge. This is for linear charge density. Linear charge density. This is for surface charge density. Surface charge density, and this is for volume charge density. Volume charge and density. ठीक है? So I'm sorry, integral तो मैंने already sign लगा दिया है, तो I should write integral dv. Okay? So this will be the definition of potential. Now let us now come to problem. पहले point charge लेके निकालता हूँ. Okay. So suppose you have a spherical shell. So now again I will take the systems we have already taken. Spherical shell. So जिसके जिसके लिए field निकाला था, now we can calculate the potential for those systems. Okay. So spherical shell is there, and this is of radius r. Let q charge is given to this shell, and the charge will spread on the surface. Yes or no? And we will take the reference potential at infinity, which will be 0 for such a system. So what will be V equal to? So if I take a small charge, say dq, and this is the distance from the center. Okay. So what is the potential because of this at this point? P. Bolo bhai.
1/4.
Yeah. O. Huh? 1 by 4 pi epsilon naught. Small potential because of this charge at the center. dq by
Capital R.
capital R. So if I integrate, the potential V is 1 by 4 pi epsilon naught Q by R. This is the potential. And don't forget, we can always tell the potential difference. So actually it is VO minus V infinity is equal to this. Okay. And by chance, here V infinity is 0 because very, very far from this charge at infinite distance, the potential will be 0. So reference potential is 0. This is reference potential. जैसे कि आप कोई दूरी बताते हो, if you tell a distance, so आप ये नहीं कह सकते, अगर मैं कहूं कि दिल्ली जो है वो 100 किलोमीटर दूर है, तो क्या ये सेंटेंस सही है?
No, sir.
No, sir.
Yes.
No, sir.
No, sir.
Is it correct? This sentence is correct?
No, sir.
No, sir.
कहाँ से?
No. Why? Because reference is missing. No?
Yes.
You can say Delhi is 100 kilometers from. जब तक from नहीं बताते तब तक there is no meaning. So ऐसे ही potential is not a complete thing. You should tell potential difference between 2 points because reference should be there. So sometimes by default the reference is at infinity, and at infinity for such configurations, for such point charges, हर case में this is not a universal concept. Please understand, not a universal concept. तो इन्फिनिटी पे हमेशा पोटेंशियल 0 नहीं होगा, बट अगर इस टाइप का कोई चार्ज है, इसकी वजह से तो इन्फिनिटी पे फील्ड 0 ही है ना, तो उस केस में हम कह देंगे कि पोटेंशियल भी वहां 0 है. ओके, सो दिस इज द पोटेंशियल ड्यू टू स्फेरिकल शेल.
सर
So,
ये कैपिटल आर का नहीं पता चल
क्या
रहा. ये
क्या नहीं?
पोटेंशियल एट ओरिजिन निकाला हमने.
हाँ,
ओके.
तो इसका मतलब पोटेंशियल जो है स्फेरिकल शेल के अंदर क्या होता है, किसी भी पॉइंट पे कांस्टेंट होता है. ओके, यस. So if suppose some plus q charge is there, and because of this at a distance a, I draw a sphere, and again at b, I draw a sphere. Let at this point potential is VA, and at this point potential it VB. So it is like this. This point is VA and this point is VB. राइट? समझ आ रहा है? बोलो भाई.
Yes, sir.
So are you able to understand this? At this point potential is VA and at this point potential is VB, right? So VA is greater than VB, na? Yes or no?
Yes, sir.
So इसलिए field will be in this direction. So that's why field is radially outward in this case. So you can understand both things. Because the potential here is higher than here. Potential is कि decreasing direction में electric field होती है. So you can see the direction of electric field. So electric field is in decreasing direction of potential. Electric field is in the decreasing direction of potential. Okay?
सर ये
अगर
पॉइंट बताना एक बारी, ग्रेटर कैसे है VA VB से?
आप बताओ VA पे क्या पोटेंशियल होगा? बोलो बोलो.
सर 1/4 पाई एप्सिलॉन नॉट.
Q by A
हाँ जी.
और VB पे Q by B.
हाँ जी सर.
तो if A is smaller than B तो VA बड़ा नहीं होगा VB से?
हाँ
मान
जी
लो
सर.
ये 2 है, ये 5 है, तो कौन बड़ा है?
5.
अरे 5 बड़ा है, लेकिन 5 डिनोमिनेटर में है ना, तो ये छोटा हो जाएगा. आप समझ नहीं पा रहे हो ना?
नहीं सर अभी हो गया.
तो ये क्लियर है? तो इस पूरे सरफेस पे सेम पोटेंशियल है. दिस इज कॉल्ड इक्विपोटेंशियल सरफेस. Equipotential surface, because this whole surface carries the same potential. So this is one equipotential surface and this is another equipotential surface. They both have different potentials, but whole of this sphere has one potential and whole of this sphere has another potential. So that's why these are known as equipotential surface. तो ये दूसरा equipotential surface है और ये दूसरा equipotential surface. Okay? ठीक है? तो what is equipotential surface? उस सरफेस के हर पॉइंट पे पोटेंशियल की वैल्यू सेम है, यानी पोटेंशियल डिफरेंस 0 है. तो सपोज यू हैव अ इक्विपोटेंशियल सरफेस लाइक दिस and at this point potential is V1 and at this point potential is again V1. So what is potential difference? 0. So how much work is done to move a charge from one point to another point? 0. So no work is done in moving a charge on equipotential surface. No work is done in moving a charge on equipotential surface. No work is done in moving a charge on equipotential surface. Okay? ठीक है?
Yes, sir.
तो इक्विपोटेंशियल सरफेस पे मूव करने में कितना वर्क करना पड़ेगा?
0.
हाउ मच
सर
वर्क
कुछ
इज?
नहीं।
कुछ नहीं, 0. और देखो, वी कैन ड्रॉ द इक्विपोटेंशियल सरफेस आल्सो. सो दिस कॉन्सेप्ट इज क्लियर ना टू एवरीवन?
यस सर।
We can move also. We can draw also equipotential surface. Suppose we have a potential V is equal to, और phi से भी represent करते हैं potential को, 1 by 4 pi epsilon naught Q by R. Due to a point charge Q, we have a potential at point P at a distance R. So this will form a sphere. How this will form a sphere? मैंने बना तो दिया, but let us calculate how it will form a sphere. So at equipotential surface, the potential is constant. So let us take that potential equal to phi naught. Phi naught ले लेते हैं उस potential को. तो phi naught will become 1 by 4 pi epsilon naught Q by R. So R will become Q by 4 pi epsilon naught phi naught. So R is under root of x square plus y square plus z square. And let us write this quantity as some capital R. I can write now? ये सब constant ही है. Let us write it as some capital R is equal to Q by 4 pi epsilon naught phi naught. This is a constant. So what is this? क्या मिल गया हमें? X square plus y square plus
सर्कल।
Sphere.
z square is equal to R square, which is equation of a sphere, which is equation of a sphere. Sphere का equation मिल गया. So जैसे से phi naught की वैल्यू बदलोगे, यहाँ पे R की वैल्यू बदलती जाएगी and you will get multiple equipotential surfaces. Are you getting it? You will get multiple equipotential surfaces. समझ आया?
Yes, sir.
और ऐसे ही depending on the potential, the shape of the equipotential surface will change. Like if you have a constant electric field, suppose electric field is due to infinite sheet. So you have seen for infinite sheet, like this was the sheet. अभी calculate किया था ना मैंने? potential was V is equal to ED, right? So if field is like this and its value is not changing, it was just sigma by epsilon naught between the plates. So equipotential surface कैसा होगा? इस टाइप का perpendicular plane होगा. If this is the field, uniform field, so these are equipotential surfaces. Because V is equal to ED hai. So at a fixed distance from, suppose that this is the reference. So at fixed distance, the perpendicular plane will give the equipotential surface. Equipotential surface. These are the equipotential surface. Okay. तो यूनिफॉर्म फील्ड के केस में व्हाट इज इक्विपोटेंशियल सरफेस?
Infinite.
Perpendicular to the planes, perpendicular to the field, the infinite planes or finite plane, whatever planes you draw, प्लेन के हर पॉइंट पे पोटेंशियल सेम होगा. इसलिए प्लेन पे अगर किसी चार्ज को लेके चलोगे तो कोई वर्क नहीं करना पड़ेगा. यू विल नॉट हैव टू डू एनी वर्क इफ यू मूव ऑन द प्लेन. इज इट ओके?
Sub condition plane should be infinite, na?
हाँ, इनफाइनाइट तभी तो ये यूनि विच सपोज दिस इज गिवन. ये तो सोर्स ऑफ फील्ड है ना. इलेक्ट्रिक फील्ड इज गिवन. इसका कॉज नहीं दिया है बट इसका कॉज हो सकता है इनफाइनाइट शीट्स, राइट, जो हम पहले भी जानते हैं. तो अगर यूनिफॉर्म फील्ड है तो इक्विपोटेंशियल सरफेस होगा परपेंडिकुलर प्लेन्स ऑन द यूनिफॉर्म फील्ड. ठीक है. सो व्हाट इज इक्विपोटेंशियल सरफेस फॉर यूनिफॉर्म फील्ड? बोलो.
Infinite planes.
परपेंडिकुलर टू द फील्ड. तो प्लेन्स perpendicular to the field, uniform field, creates equipotential surface. Is it okay?
Yes, sir.
तो जो शेल मैंने बनाया था इससे पहले उसमें ग्राफ बनाना भूल गया. तो ग्राफ बना सकते हो कि उसका जो पोटेंशियल है वी एफ आई जिससे भी लिखते हो, उस शेल के अंदर तो कांस्टेंट होगा बट बाहर कैसा होगा?
Decreasing.
1/r. So this will be the graph for a shell, for a potential. ये पीछे बना लो शेल वाले में. ओके. चलो फिर अब आगे डिस्कशन करेंगे हम लोग नेक्स्ट क्लास में. जल्दी ही एक थोड़ी लंबी क्लास रखते हैं जिसमें हम लोग ढेर सारी प्रॉब्लम्स एक बार में ही डिस्कस कर लें. वही काम जो 2-4 दिन में होना है वो अपने आप फटाफट हो जाएगा. ओके. क्योंकि अब
यस सर.
समझ आ ही रहा है आप लोग को, तो अमाउंट ऑफ प्रॉब्लम्स जो है ना वो ज्यादा डिस्कस करने के लिए आई विल डू दैट सून. ओके. थैंक यू.
सर मेरा एक डाउट है
हाँ.
सर, मतलब इससे रिलेटेड नहीं है सर. 0 × -∞ 0 क्यों होता है? मैथमेटिकल एक्सप्लेनेशन.
अरे ये सब छोड़ो यार.
मतलब ग्राफिकली समझ में आ गया था, एक इंटीग्रल में था प्रॉब्लम आ रही.
इंटीग्रल में कहीं आ रही हो तो वो भेजना.
ठीक, उसमें आया सर, मैं प्रॉब्लम भेज देता हूँ.
हाँ.
ओके सर.
Thank you, sir.